This is a cool little professional rack mount amplifier. Probably the smallest one I've ever worked on. I think it's only rated at 30 watts per channel into 8 ohms. But it is built like a tank and it is much heavier than it looks. It's a BGW Systems Model 100. I think it's the original 100. From what I've seen, they have newer ones like a 100B and several larger models. But I saw an inside picture of this and got it on eBay for like $45 including shipping, and I thought it'd be a cool project. They said it didn't work, but I really like the older designs like this, and this thing just looked cool and kind of caught my eye, so I thought it'd be a fun project. In fact, it's so old that it uses transformers for balanced inputs, and these jumper plugs here pull out and they're like an octal tube socket, and you buy a certain specification of transformer depending on what kind of input you're using. And with a jumper like this, it's configured for unbalanced input, but you can still use the XLR, which is handy because my test bench is set up for that. But I'm going to take the top off and have a quick look inside, and we'll go from there. Here's what the inside looks like. It's quite vintage. The date codes on the components all seem to be about 1978. And can definitely tell, looking just at the way the circuit board looks, it's definitely period. It's old mailery capacitors. Everything in this is made in the USA. I don't think there's any imported parts in this amp at all. That's how old it is. And it's so much heavier than it looks too. I mean, the metal is very thick on this whole thing, and even the top cover had some major weight to it. But seems to be very well built, but I'm still expecting to have to buy a new set of output transistors and a few capacitors. There's see what's in here. Looks like there's 3 tantalum capacitors per channel and 2 electrolytics, so it'll be a very easy recap job. Almost everything is direct coupled in this, and there are no bias adjustments. It's all self-biasing. It's got MJ1505 output transistors, and the other ones appear to be house numbered RCA transistors, so I'm not really sure what those are. I think they've been replaced at some point in time, because looking at the schematic it shows house part numbers on the outputs as well. But designs like this are pretty forgiving, and I should have no problem using more modern transistors if I need to. I might have to change a couple of resistors in the circuit to compensate or anything like that, if anything. And the input stage is an op amp, which is a LM318, and even though it's in the metal can style, the circuit board is drilled for a dip style layout, so I could use a standard modern op amp in there. They still make the LM318. In fact, it might even give me some room for upgrade, improve the performance. But I guess I'll find out when I start digging into it. I'm going to give it a quick test after I check some things over and see what it does. One thing I did notice though is that these jumper wires on the back seem to be kind of touching each other, and they probably shouldn't be, so and make sure those are not shorted before I power this up. That'll definitely cause problems. And physically it's in decent shape too, other than one of the knobs is missing the aluminum cap and the other one came off really easy. But I'm not worried about that. I can get better looking knobs to put on there at a later date. So this will be a cool little project. Well, it's somewhat working. I got to replace the power switch because it's broken. And one channel sounds decent. But this one's definitely got a problem. Definitely sounds like blown outputs. At least one of those transistors has got to be open. It looks like the emitter resistor back here got hot too, and the other ones don't have that discoloration, so I'm about willing to bet one of these outputs is shorted, and I'm only getting part of the signal. And the more I turn the volume up, it seems like the more bias it has, because the I get less and less distortion, and I hear more and more of the what I would call the duty cycle of the signal. And it's got lots of volume despite the distortion, so I know that there is some voltage boost going on. It's just part of the signal path is probably open, so definitely got to do some work on the right channel. But judging by how this side sounds, I think it's going to be a nice sounding amp when it's done. Now that's convenient servicing. Just remove the bottom plate, everything stays in place, and you have total access. I love the construction of this amplifier. But check out this heat damage. Definitely had some resistors get hot, so it looks like all three of them. So we definitely have a problem going on in the output stage here. It's unfortunate. I also noticed that the volume doesn't go all the way down. I wonder if that's designed like that on purpose, or if it's just something wrong with the potentiometer. But I can't turn it all the way down. But anyway, I'm going to turn this thing off and start taking some readings. I wish I had my good meter here, but for now I'm just using my workshop meter. It'll give me a rough idea of what transistors I need to order though, and I'd like to get them ordered tonight so that I can get them by Friday, but that's going to be a stretch. Well, this is kind of an interesting symptom here. If I've got both volume controls set to a low level, about even with each other, and unplug the power, the right channel actually starts to play, and depending on how loud the sound is, it actually sounds somewhat normal for a couple seconds. And that tells me a couple things. One, that the filter caps are probably still in pretty good shape to have that kind of reserve. And two, I'm wondering if there could be a problem with the input stage. With this being a direct couple design with an op amp on the input, if this op amp is shorted to one of the supply rails internally, it could be putting a ton of DC voltage into the output stage, which would cause it to constantly conduct and do things like this and blow the transistors. Well, this confirms my theory on the input stage. Looking at these op amps, pin 6, the output. Looking at the good channel, I have almost nothing for DC, which is good. But on the bad channel, I have 8.8 volts. So that explains why the output stage is toast. It's been putting DC into it. So now I know I'm gonna have to replace those op amps now. See what else it took out in the process. Well, removing the board from the frame was simple enough. Just 4 bolts on the heatsink, and then unbolt the potentiometers, and then there were several wires that were plugged in with these little connector posts. Make a note of where they go and just pull them off. And I can see exactly what burnt now. Like I suspected, it's just some emitter resistors. And amazingly, I did a quick check of the outputs using the diode test on this meter, and they didn't appear to be shorted, so maybe the emitter resistors took all the abuse. And I've also got a close look at these capacitors now. I can write down what I need to order and get the parts on the way. I don't know if I'm going to get this stuff in time to fix this over the weekend or not, but if not, it'll be for next week. Well, here it is Monday evening. Normally I don't work on projects like this on weeknights because I'm usually too tired from working all day, and there's usually just not enough time before bedtime for me to dive into something like this. But I made an exception because I want to make some progress. I've got a lot of projects piled up and I need to get something done, so got all the new parts in for this today, and I've got capacitors, resistors, transistors, diodes, op amps, pretty much anything I'd need to fix this regardless of what's wrong. So First off, I'm going to replace all the caps. I know that's got to be done regardless, and all the emitter resistors as well, because I need to get those changed out, especially on the bad channel here. And we'll do a quick test after that and see how it's working. This is something I haven't seen very often. Usually when they would insert components at the factory, they would bend the leads over to secure it to the board before soldering, like I've done here with this new resistor. But the original components, instead of folding the leads over, they put them through and then kinked them flat to make them wider than the hole, so they can't just pull back through. And I thought that was kind of unique. You can see on the back of the board from the heat damage, I've actually had to make the solder joints extend a little farther down the trace because they were lifted from the board. And just got to scrape a little bit of that green solder mask off and bend the leads over. Kind of use the component lead to anchor the component and to hold the trace in and give a nice solid point to solder to. Try to get some focus on that there. Had to do that on both of these resistors. Over here you can see what it would normally look like. I just finished putting these in, and the traces are in perfect condition over here. Okay, the board's back in. I've still got a couple of tantalum capacitors I want to replace, but I've got the new op amp in on the right channel there and all the resistors replaced. I took out all of the old carbon composition resistors and put in modern ones, much more precise and reliable. And one thing that really cracks me up still to this day is the size difference between old capacitors and new ones. These are 33 microfarad and the original ones were 20, and they're still 3 times the size. But anyway, I've got my shop meter hooked up, my variac, and a 15-watt light bulb for current limiting in case something is wrong. The meter is connected to the right channel speaker output. I'm going to check for DC offset as I power this up slowly. However, I don't know if this light bulb is going to be enough for even the idle current of this, and also not sure how the op amp is going to behave at low voltage either. So I just don't want to burn up those resistors because I can't access them underneath this metal without taking this board all back out. Anything else is not so bad, but let's see what happens here. Well, I'm at 50 volts. Light bulb is not even glowing, and the power LED is on dim. So I don't think there's any dead shorts. In fact, I'm still not getting any DC offset. That is assuming that my meter is working correctly. Just to check that, I'm going to put it across this filter cap here. Let's see. Yeah, my meter's working, so that's a very good sign. Let's bring the voltage up a little bit more. It's up to about 90. Still no DC offset and no glow from the light bulb. This thing pulls almost no current. In fact, I think I'm ready to put a signal into it and see how it sounds. Alright guys, first real power up with speakers and signal connected. Let's see how this goes. Wow, 50 volts and it already sounds good. Beautiful. I'm not even done with it yet. hard to believe that one little op-amp can cause all that chaos. But what's even more impressive is that these output transistors took all that abuse. Gotta love them Motorola's, man. There's a reason why those are still my favorite thing to use. They're owned by ON Semiconductor now, but I still prefer those over any other. Let's find a track that's got some kick to it, shall we? This thing jams out pretty good. In fact, it sounds great. Look at that. Still not lighting up that little light bulb. This thing's really efficient. There we go. That is quite loud. In a little bit here, when I finish it up, I'll find out how it sounds right at the point of clipping. So far, I'm impressed. I've got everything hooked up to do the output test. I forgot that I don't have my good meter here with me right now, and I don't think this one is true RMS, so it's probably not very accurate above 60 Hertz or so. But I've still got this little 15 watt light bulb hooked up in series for current limiting, and I forgot to take that out. And it's kind of neat to see the, I bring up just one channel here, and as I hit clipping, the bulb starts to glow bright really quick, and bring up the other channel so that it draws more current from the supply. It actually causes, you can see it make this channel sag as the supply voltage drops even more, and the bulb's getting pretty bright. And I've only got 6.5 volts AC going into the load, which is less than 8 watts. And I'm going to take this light bulb out of the circuit because I don't need it anymore. Oh, that's better. I've got 15.5 volts right before the onset of clipping. That's just with the one channel though. I'm not sure how much it's going to sag when I bring up the other channel. So I'm going to move the scope over to the channel that I just repaired and see what I get there. I moved the meter over too. Okay. I'll bring this channel up. Yeah, see, and that one's pegging sooner because of the other channel pulling current. And notice that the clip light is now on for that channel as well. Back that off just a bit. There we go. Yeah, I got both of these at the right at the onset of clipping according to the LEDs. Let's see what we got here. About 13.5 volts, give or take. I want to go back to the other channel here. I need to hook up my other lead and run my scope in dual channel, but I'm just a little too lazy right now. There's the left channel. Let's see the other one here. And the right channel. Look like they're tracking about evenly. Let me do turn this down here. Get my friend Casio out of the cupboard. Let's see what we're getting here. Find the amps. I equals E, which is 13.5, over R, which is 8 ohms, equals 1.69 amps. And to find that, we'll times that by power equals current times voltage, so times 13.5 equals 22.78 watts per channel. Of course, like I said, this meter is probably not true RMS, so I'm probably getting quite a bit more voltage than what this is actually reading. So out of curiosity, I'm going to go set my signal generator program over there to something lower, like 60 or 100 hertz, and try this test again. I'm really curious about this multimeter. Alright, I was just being a dork. That's what happens when you work tired. I forgot that I had my variac set to about 110 volts instead of 120, and that allowed me to get a clean 15 volts out, which is closer to the 30 watts per channel that this thing is rated for. So it was just me being dumb. Pretty much all that's left to do now, for the most part, is preventative maintenance. I want to replace the op amp in this channel before this one goes bad. I'll install a socket and a new chip like I did over here. And I'm also thinking about replacing the Zener diodes that supply the op amps with plus and minus 10 volts. They operate as a shunt regulator off of the B plus and B minus lines off the power supply, which I think are plus and minus 36 volts. And they shunt their unused voltage through 1K series resistors. It's a very simple voltage regulator, but it works. And in fact, that's what these some of these capacitors down here are for, filtering the plus and minus 10 volts. So, trying to think if there's anything else I wanted to do to this. Yeah, really just the usual, clean the controls and all that good stuff. And, I was thinking about also trying a couple different types of op amps in these sockets to see if it affected the performance any, but that'll probably come at a later time. Right now I just want to spend some time listening to this and enjoying it a bit. Maybe on the weekend I'll have some more time to mess around with it. I'm just going to spend my last few minutes that I have before getting ready for bed giving this thing a listen, and I gotta say, a working power switch is a wonderful thing. Check out how long this thing keeps playing. It's pretty good filter caps in that, because that's a decent volume there. But anyway, I'll polish this thing off probably this weekend when I've got more free time, but I'm just going to sit back and enjoy this one for the rest of this night, and I will catch you guys later.